Alright, so we're now going to be looking at how to integrate using partial fractions. This isn't really like a rule like the integration by parts or substitution, it's just dealing with partial fractions, which we've learned in chapter number 1. If you are unfamiliar or have forgotten about how to do partial fractions, maybe go back and refresh yourselves on those videos. The link is here above me. Alright, so let's look at this here. We're asked to integrate. Well, if you look at part B straight away, we're asked to integrate and find the exact value of this fraction from limits 1 to 2. As you can see, it's like quite a complicated fraction, but what we can do is actually split it up into its partial fractions. So let's go about doing that. So first things first, we now see that the numerator is actually larger than the denominator, right? Because it's 32x squared, whereas the denominator is 16x squared. So we can actually do algebraic division. So I need to expand this first, right? So 4x plus 1, 4x minus 1 will give me 16x squared minus 1. So hopefully you guys remember how to do algebraic division as well. So we're going to have 16x squared. There's no x term, but I still need to write the x term here, minus 1. And I'm going to divide it by 32x squared plus no x term, but still write plus 0x plus 4 like this. Right, how many 16x is going to 32x squared? Well, that's just 2, so minus open bracket, 32x squared plus 0x minus 2, close bracket, and this will give us now 6. So the initial fraction, I can rewrite it as 2 plus 6 over 4x plus 1, 4x minus 1. Right, we still need to use partial fractions to split up these two here, right? So we're going to have 4x plus 1, 4x minus 1. And this I'm going to split up into a over 4x plus 1 plus b over 4x minus 1. We now combine them together again, remember? So a times 4x minus 1 plus b times 4x plus 1. And that's equal to 6 because now the denominators are the same. I'm going to use the substitution method. So let's say let x equal to. To get rid of this a, it's going to be 1 over 4. So therefore 6 is equal to b times 4 times 1 over 4 plus 1. So 6 is equal to 2b, b is equal to 3. To find a, I say let x equal to now negative 1 over 4 because I want to get rid of the a term. So therefore 6 is equal to a times 4 times negative 1 over 4 minus 1. 6 is equal to minus 2a. So therefore a is equal to negative 3. So this original fraction I was given, I can now rewrite it as 2, remember the 2 before, minus 3 over 4x plus 1 plus 3 over 4x minus 1. And now they're asking us to integrate it, right? So we're not integrating this dx, and the limits were from 1 to 2. So this partial fraction is what? It's not actually integrating it, we're just rearranging or substituting it or manipulating into more simple fractions, which we can integrate now. So once we got this, it's just a matter of integrating. So we should know how to integrate these kinds of stuff. So this 2 is easy, this is 2x, right? This one here, it's 4x plus 1, so it's going to give negative 3 over 4 ln 4x plus 1. And this is going to give us 3 over 4 ln 4x minus 1. And this is from 1 to 2. Right, because we have some ln terms, I can actually combine it because we can use the ln or the log rules, right? So this is going to give me 2x plus 3 over 4 ln. Minus means divide, right? So it's going to be 4x minus 1 divided by 4x plus 1, like this. Still from 1 to 2. And now I can just plug it in. So we're going to have 2 times 2 plus 3 over 4 ln. This is going to give us 8 minus 1 over 8 plus 1 minus 2 times 1 plus 3 over 4 ln 1. So 4 minus 1 over 4 plus 1. So what do we have here? We have 4 plus 3 over 4 ln. This is 7 over 9 minus 2 minus 3 over 4 ln 3 over 5. And we want to simplify as much as possible. So this goes 2 plus 3 over 4. So this negative, I can say is 3 over 4 ln. Negative, I can swap this around here, right? So it's just using the log rule. So I'm going to rewrite as 3 over 4 ln 5 over 3 plus. So this will give me 7 times 5 over 9 times 3, which means we have 2 plus 3 over 4 ln 35 over 27, like this. So the actual integrating part isn't too difficult. It's more the fact that, well, before we actually have to integrate, we have to use the partial fractions to split them up into more simple fractions for us to integrate. So this is just not really a rule, it's just how to deal with fractions which can be split up into partial fractions.